Hi everyone and Assalamualaikum. My name is Siti Nur Emilia binti Fadila, and as a part of our group's presentation on the topic stuttering and fluency disorders, my segment will specifically focus on how these disorders actually relates to our brain anatomy and the speech functions. For a very long time, society mistakenly believed that stuttering was purely a psychological issue, and that people stuttered simply because they were nervous, shy, or anxious. However, modern psycholinguistics and neuroimaging shows a completely different reality. Stuttering is actually primarily a physical neurological condition, deficit in our brain-speech network. To make this incredibly simple for you to understand, I want you to imagine the speaking brain as a post office system. For a word to be spoken fluently, a package must be wrapped, sent down smoothly down the highway, and must be delivered on time. Let's look at 3 specific areas where this system encounters a glitch in a person who stutters. First, let's talk about the planning stage. In the left hemisphere of a typical brain, there is a crucial region known as the Broca's area. In our post office analogy, Broca's area is the main planning office. The job is to formulate the speech plan, meaning the Broca's area programs the exact motor instruction for how your tongue, your lips, and how your vocal cords move to produce a specific sound. Neuroimaging studies shows that in a person who stutters, their Broca's areas is consistently underactivated. This means that it did not receive enough neural power or coordination when a person tries to speak. The individuals actually knows exactly the word they want to say, but their brain's plannings experiences a delay in their motor commands. This delay is the primary reason why a person might experience a pause before a word can even begin. Secondly, once a speech plan is finally made, the speech plan has to travel from the brain down to the muscles of your mouth. It does this by traveling along a massive highway of nerve fiber, which we call as the white matter pathways. When psycholinguists look at the diffusion tensor imaging, which maps the brain's wiring, they find that individuals who stutter experience a reduced structural integrity in their left hemisphere white matter tracts. In simple terms, the speech highway has what we call as potholes. Because this connection is weak, the timing of the signals to get to the mouth actually get disrupted or drop along the way. The signal actually arrives, but it arrives in fragments, which physically forces the speech mechanisms to repeat a sound. For example, the stuttering of like ball, or also prolong it while waiting for the full neural command to cross the highway. And that brings us to our third major finding, which is the right hemisphere hyperactivity, or we call it as overactivation. In a fluent speaker, speech is heavily processed on the left side of the brain, but because the left side of the brain of a person who stutters fails to function, the brain does something fascinating, which is it forces the right hemisphere to kick in as a backup engine to help push the words out. While this right side compensation allows the person to speak eventually, the right hemisphere is actually not naturally designed to handle the fast and sequential speech movements. As a result, the speech delivery becomes choppy, hesitant, and strained. This is what we see as stutter. What we see as a stutter is actually the visual and the auditory result of the right brain working overtime to fix a left brain transmission issue. In conclusion, understanding the brain and speech function actually changes everything we know about the fluency disorders. My deepest reflection from researching this topic is realizing how unfair it is to tell someone who stutters to just relax or slow down. Stuttering is actually not a lack of confidence, but it is actually an issue that came from a neural timing. Thank you so much for your time. I hope you learned something new from my presentation. Bye!